Now we're going to go over two methods of making ellipses. The first method we call the two-circle method. So I'm going to draw two circles, one representing, make it fairly big, the major diameter of the ellipse. And then the smaller circle, it's going to be an arbitrary size, will represent the minor diameter or minor axis of the ellipse. So here I have my two circles. All I have to do now is draw a line through the center of these two concentric circles. And it really doesn't matter at what angle, but I'll try something close to a 45-degree angle. As long as it goes through the center. Okay, that's a construction line. It's a little dark for a construction line, but now wherever that line intersects the small circle, I'm going to draw a horizontal line. And wherever that line crosses the large circle, I'll draw a vertical line. Where those two lines meet will be a point on the ellipse. So I'll do that. So every line I can get 2 points from. So here's a point that'll be on the ellipse, and here's a point that'll be on the ellipse. Of course, this will be a point on the ellipse, this will be a point on the ellipse, this point will be on the ellipse, and this point will be on the ellipse. So the two circles themselves with a vertical and a horizontal line through it, or at any angle really, will give me 4 points immediately. So just a couple more lines. Really, the more lines, the better. Let's try another one this way. Okay. Horizontal line through the point at the small circle. Vertical line through the big circles. Oops. There's one. This can get rather confusing. So it's good to do one line at a time. So there will be a point. 2 more points. Let's try a couple different angles. I'm just going to miss that. I have to slide that up. Another 2 points. Okay, 2 more, and then we'll go into how to draw the ellipse with the points that we have. Really, I should have a couple lines through at some good other angles. Usually a 30-degree angles work pretty well, but I'm just drawing arbitrary angles. Start over. There's a point. In the interest of time, that'll be all the points I'm going to use. But realistically, I would want a line to clear up this space, or to fill up that space, and maybe another line through these two quadrants to get 2 more points. But let's say I have enough points. The next thing I want to do is get the French curve, or your irregular curve, out, and we're going to connect these points. And so using the irregular curve is a bit of a chore, or it takes a little bit of practice. Anyway, I'm going to find a curve that will pass through 3 points. I don't want to draw it past that because it's not going to, the rest of that curve won't pass through where I want it to. But then I'm just going to just fit the points as I see them. So that worked well for these points. So I'm going to do the same thing over here. And try some more curve fitting. So just using the irregular curve at various portions on it for the ellipse, I can get my ellipse drawn. Keep in mind tangency, so I want the peak of my irregular curve to be at the end so I don't get a pinching at the ends here, which I sort of do here already, so I wasn't being careful. And this is going to be horizontal here, so I want to be sure to make sure it's going to be a nice horizontal start. And just going quickly, move that curve until it passes through. And a little bit more. Looks like it might work. And try these 3 points. So take 3 points at a time. Usually that does best. That's going to be a little bit off here. Got to be in here somewhere. Darken it in. Darken it in with the irregular curve, but in this case I'll just do it by hand. Kind of missed that point there, that's why I'm getting a little pinching at the end. But hopefully this demonstrates the general idea of how to get this ellipse using the 2-circle method. The next method is a little bit easier, a little bit quicker anyway. I'm going to get another piece of paper and I'll call it my Trammell. This is called the Trammell method. I'm going to fold a piece of paper so I get a nice straight edge. So here's my folded piece of paper. And I need to mark off, and I could use circles for this or just a scale. So I'm going to use a scale, and I'm going to, how about a 3-inch major diameter? So I'm going to put it mark at 0 and 3, centered at 1.5. And then maybe, how about a 2-inch minor axis. So now I have my minor and my major axes marked off. And in this case, I'm going to make a mark on my Trammell, or my folded piece of paper. I'll call that the origin, call it O. And then I'm going to mark off the major radius, so from the center out to the end. Okay, I'll call that point A. I'm going to do the same thing for my minor radius. I'm going to make a mark on my Trammell at, call that, I guess, point B. Now all I have to do is line up A on the minor axis and B on the major, so I'm inverting that. So if A is on the minor axis and B is on the major axis, like I have it here, O will be a point on the ellipse. So all I have to do is slide this thing around and line it up at various points. So this is a very fast method of generating my points. And you'll notice I can get to here. At the endpoints, it'll be straight along one of the axes. So I'm not being really careful here, but just quick. I can get a lot more points and thus have the potential of getting a smoother looking, nicer ellipse. Continue on in this quadrant. All the while keeping B on the minor axis and A on the major axis. I mean, the other way around. B on the major axis, A on the minor. Keep going. A couple more and I'll be ready to use my French curve again. Good enough. At this point you can see how this ellipse is shaping out. There's 3 points. Open this up for another. I'm going to try to cheat and grab more points, and sometimes this is, well, that was a good one. In fact, I'm just going to flip that over for the other side. It was so good. Now, that was really cheating, and so I got a little pinching on the end there. But this turned out okay. Missed a point there, but still, there's an ellipse using the Trammell method.